So let's run through 47. I think this was maybe the worst one on here. Was a bit of a doozy. So what I'm going to do is I'm going to start by working on the left-hand side here. And I'm going to start by writing everything in terms of sines and cosines. At least in the first fraction. And what I'm going to do now is I'm going to basically kind of clear the fractions in this first piece. So notice that in the numerator, the fraction has a denominator of cosine. And in the denominator, the denominators are 1 and cosine squared. So the least common multiple of those is cosine squared. I'm going to multiply the top and bottom of this fraction by cosine squared over 1. And I'll simplify that in a moment. In the second fraction, though, I'm going to do something extraordinarily sneaky. So I'm going to rewrite 2 cosine squared as cosine squared plus cosine squared. So when I multiply here, I'm left with the 2, the sine x, and a cosine x. When I multiply the denominator, I have a cosine squared x, and then minus sine squared x. With this other piece now, I'm going to observe that cosine squared minus 1, remember that we know that 1 minus cosine squared is equal to sine squared. So negative 1 plus cosine squared equals negative sine squared. Right? And that's what I have here. Is everybody okay with that? You'll notice now we have common denominators, right? Oh, yay! So I can write the numerator as 2 sine times cosine plus 1 all over cosine squared minus sine squared. What do I want to do now here? I thought I would have something more obvious to deal with in the numerator. Oh, okay, I see what to do. All right. Who's ready to get real sneaky? Here it is. Here it is. I'm going to rewrite 1 as... What is 1 the same thing as? Sine squared plus cosine squared. And you might ask yourselves, why in God's name would you want to go backwards and make it look worse? Here is the reason, is because this is now like a quadratic that's factorable. It's basically like x squared plus 2xy plus y squared. And the denominator is like x squared minus y squared. Does everybody see that? Where like x is sine x and y is cosine y? You guys buy that? Cosine x? So x squared plus 2x plus y factors to x plus y times x plus y. And x squared minus y factors to x plus y times x minus y. So those things cancel. So I really just have x plus y over x minus y. And if we substitute in here for sines and cosines, that is sine x plus cosine x times sine x plus cosine x. And we have sine x plus cosine x times sine x minus cosine x. And those cancel. And I'm left with sine x plus cosine x over sine x minus cosine x, which is what we're supposed to have. That was sneaky. There's many other ways to get to that final answer. I don't know if that was the best way or the most efficient way, but that's the way that I tried to do it. I thought this was by far and away the worst one on here. Allison. I meant Abigail. So let's go and look at the other one. I would not expect you to be able to do something that difficult on a test. I thought that one was quite tricky. This one I think is considerably not nearly as bad. So I'm going to choose to work on the right-hand side here. And the first thing I'm going to do is factor that piece because it kind of looks like a quadratic. You guys agree with that? Oops. But it's more, sorry. Yeah, this is fine. Where x is equal to cosine squared x. I guess I could write y's. That's probably less confusing. Everybody okay with that one? You stupid computer. Okay. So if that factors, that's going to give me basically 1 minus y times 1 minus y. And then I still have that sine x coming down. And y is cosine squared x, we said. And what's cosine squared x the same as? 1 minus cosine squared is the same as sine squared. So I have sine squared x times sine squared x times sine x, which is just, if I add up the exponents, sine to the 5th x. And we're done. What? it easy, guys. This one looked kind of bad, but it wasn't so bad, right? Didn't have to do like a bunch of weird things. It did one factoring and then a Pythagorean identity, and we're done. What time does this class end? 5 minutes. Let's stop here. What we're going to plan for tomorrow, I'm going to give you another homework assignment to work on in class, though. So we're just going to take the entire time in class and work on some of these verifying things. I'm doing that intentionally because I know this is one of these things where getting feedback in real time is important. So I'm doing this with the intention that you're going to come and ask me like, hey, this isn't working out. Have I made a mistake here, or should I do something different, or what should I do next? And I can give you that feedback in real time because I know that this is not the easiest thing that I'm asking you to do in the world. And I know that developing some intuition as to like what to do next isn't always obvious and hard to do just on your own without getting a lot of feedback. So that's why I'm going to do this. So tomorrow in class, we're just going to work on these kinds of problems. Anything you don't finish in class, you could take home. And we'll just package it into the Friday homework turn-in. So the Friday homework turn-in is going to have everything from 5.1 and 5.2 that we've done it. Just FYI. So that's the plan for tomorrow. Hi, Lane. Thanks. Yeah, the 2 problems, if you haven't turned them in yet, please drop those off before you leave. The 2 problems, if you didn't turn them in yet, drop those off on the desk before you leave, please. Thanks, boss. Right there, Dan. Yeah, right now. Open that for